Yes, Priyanka? Both of you turn your cameras on, and by the way, Priyanka, you are not audible, by the way. Today we are going to begin with a new chapter. Meanwhile, before we begin with the new chapter, you guys update me with what's going on in the school. Yes, Abu and Priyanka.
So
Currently,
the chapter basis and salt is going on.
okay, that is finished.
It is going on.
Okay, this is still going on. Okay, okay. And any updates regarding your exams, when your exams are going to commence from? Any
Sir,
updates? Yeah.
Sir, it is going to the exams will be from next week.
From next week. Okay. Did you share the syllabus?
Sir, I'll share you now.
Yeah, now share it with me. Okay, it is very important. Like, it's kind of understood that whenever you get the syllabus, the first thing that you need to do is share the syllabus with me. Okay, now. Yep. Priyanka, you're not audible. Try joining the class once again. Share the syllabus with me. The first thing that you need to do whenever you get the syllabus is share the syllabus with me. Okay, no. Today we'll be beginning with a new chapter, by the way. Before we move on, do tell me, when an acid and base reacts, what are the products you obtain? What are the products obtained?
Salt water.
Salt and water. Very good. Okay. And do tell me, we understood about, apart from synthetic indicators, we learned about some natural indicators also. Can you guys give me some example of natural indicators? What are the natural indicators which we have? There were so many.
Turmeric paper.
Turmeric can be used as a natural indicator. Very good. Apart from turmeric, any else? Any other examples? Apart from turmeric, there are so many examples, no? We learned about methyl orange. Huh? We learned
Sir,
about some of the
sir,
olfactory indicators. Yeah.
red cabbage,
Red,
hibiscus flower.
red cabbage juice is also used. Huh? You should know that even sometimes grape juice is also used an acid base indicator. Then we had the example of different types of olfactory indicators. We have the vanilla extract. What else? Tell me. Apart from
Sir,
vanilla extract,
flower.
clove and onion. Okay, na? Clove oil, onion juice. We learned about all of them, no?
Yes.
Make sure that you keep on revising the things. Otherwise, you will tend to forget the things. Okay. Okay. Is Priyanka back in the class? Yes, Priyanka. Let me just give me a minute. Let me just erase the writings of the previous classes. In the chapter, we are going to start this chapter today, and there are different interesting things we are going to learn in this chapter. We are going to learn about different type of changes that are continuously occurring in our nature, and how each change is distinct, each change is unique in nature. All right now. Okay. Hope screen is visible to everyone. Priyanka. Yeah, Priyanka, I can see your message. I believe you're Apu. By the way, I'm properly audible to you, right?
Yes, sir.
Okay. From which device you guys attend the class? Is it from a smartphone or from a laptop? See, Priyanka, do one thing, just give me see if I can do. Okay, Priyanka, you're attending from a phone. Let me see if I can do something. Mm, then- no, that's not helping. Remove pin. Is my screen visible to everyone? Hello? Okay. Abu, is it visible? Okay. Let me just remove myself from pin. Oh, okay. So we are going to learn about physical and chemical case. Okay, as of today's class, Priyanka, just do one thing, just listen to what I'm saying. And whatever questions you have got, please put it in the chat box. Okay, now? So let us learn about the changes. See, every day we come across different type of changes that are continuously happening around us. Some of the changes may involve one or more substances. Huh? For example, you get that sometime milk turns sour now. So milk turning into sour is what? Guys, just hold on for 1 minute. Someone's on the door. I'll be back in a minute. Yeah, sorry for the interruption. So I was saying that every day we come across different changes that are happening around us. Huh? We come across changes. The most common change that you can observe in your house also, like sometimes milk turns sour. Huh? Sour milk turning to sour taste. It's a change. Yes, Abu.
Sir,
Isn't
how does milk change sour?
how does milk change sour? See, if bacteria starts to grow in the milk, if bacteria starts to grow in the milk, then it turns to sour taste. Getting it? That is one thing. What bacteria is growing basically in the acid? It's a lactobacillus acid. Right now. So when acids turn sour due to bacteria in it, that's a change. There you get to see that milk starts to slowly milk starts to convert into curd. Getting it?
Yes, sir. Sir, my mother today, she did something,
Mm-hmm.
and then the milk, like, it became like weird shape. And then she took a cloth, she put it all inside, and then there was like water coming out of it.
Okay, I think that she might be making this thing, like it is. I think it is paneer. It is called as paneer.
No, sir. Paneer, I think it is like cheese, but then with that, she made some kind of sweet.
Oh, okay, okay. That might be something. I'm not particularly aware of it. By the way, but we can simply conclude that these are the changes that are taking place around us. Particularly that the milk turning to sour, it's a chemical change. Or for example, uh, many times to make a sugar solution, huh? Solution of sugar, that is also change. The sugar crystals seems to have disappeared into the water, but what kind of change is that? Hmm? Can we obtain the sugar crystals back from the sugar solution? Can we do so? So that's, we see that here we can do that. Upon crystallization we can get it back. Once the water is evaporated, you take some sugar crystals in a glass, you make a solution out of that. You will see that the sugar crystals disappear. And where does that they disappear? They basically disappear because there are some empty spaces in the water. In the water there are some empty spaces in the water. In class 9 you will get to understand that in detail. So in those empty spaces sugar crystals disappears into those empty spaces, but it can be obtained back by via evaporation of that water. It can be obtained back, so thereby that kind of change is called as physical change, where you can obtain the product back. While those kind of changes where you can't obtain the original product back, like once the milk turned into curd, is it possible to turn it back into milk? Yeah, Abu and Priyanka, that isn't possible, no? So
Yes.
hope you guys are getting it. So we have observed some other changes around us also, like melting of ice or making of ice cream, or melting of wax, stretching of a rubber band or evaporation of water, or like cutting of paper or breaking of glass plane, bending of a glass tube by heating it, getting it, or simply the boiling of water, or you have sublimation of camphor. You know about sublimation? What is camphor? I believe you guys know about camphor. See, basically talking about like camphor is a chemical that is used from the wood, that is made from the wood of a tree, uh, and it has got a very distinct kind of a smell. It has got a very distinct kind of a smell, and it is used in medicine also. Right now, camphor commonly we call it kapoor. You guys know about this? Camphor commonly it is called as kapoor. It comes in forms of a white tablet like a structure. It's a thick tablet like a structure. Hope you guys can relate it, can understand what I'm saying about. So camphor, it directly converts into its gaseous state without converting into the liquid state. So camphor goes through, we say that it goes through sublimation without converting into liquid. Normally what happens, like when you condense the water vapor, so water vapor first of all converts into the liquid state, getting it now? But here what happens, this camphor directly converts into the gaseous state without going through the liquid state. So that is uh, sublimation. So all those examples which we had, whether it be melting of wax, making of ice cream, we learned that these are the different changes that we see around us, and those changes can be categorized as physical and chemical changes. So talking about the physical changes, in the case of physical changes, what is going to happen here, you will get to know that in the physical change, only the physical aspects of a substance is going to change. Right now, like their shape, size, or their color and their state can change, while the main composition of the substance will remain same. If it is water, it is going to remain water. If it's a rubber, it remains water. Right now, if it's a paper, it remains a paper. Hmm? So you have got different physical changes in nature, like crushing a can, the shape has deformed. Getting it, guys? The shape changes to something else, but it still remains a can. No? I mean to say the thing, like it can is made using tin, so it still remains tin. Melting of an ice cube or boiling of water, so it still remains the same thing. Then mixing sand with water. So you have mixture of sand in water. But is it that you have obtained a very new thing? Huh? You have obtained a new product, and the property of that product is different of sand and water. No, it is not very different from the um, sand and water. It is basically a mixture, breaking of glass. Although this is an irreversible change, you can't get back the same glass. Um, so here it's an irreversible change, but it's a physical change. It still remains glass even after breaking it. Or chopping of wood, or dissolving sugar in water, shredding paper, sublimation of dry ice. Dry ice, it basically refers to carbon dioxide, solid carbon dioxide. You might have seen that solid carbon dioxide. This is used in stage performances. In the stage performances, like I mean to say, solid carbon dioxide would be used in the stage performances. How and why basically it is used? Hmm? Because solid carbon dioxide is extremely cold. First thing is that it is extremely cold. The temperature of solid carbon dioxide is minus 78 degrees Celsius. Okay, now so there are different uses of it. Like when it is used in the moments so I was saying that like it is in a stage performance it is used. So upon putting it into the outer environment, it releases fumes. What does it release? It fumes. So it creates some special effects upon releasing right now. Or apart from that, it will be it is particularly used in storing the vaccine, of food preservation also, freezing different body tissues of humans, freezing blood, uh, freezing for some food sample of freezing tissue sample. Are you guys getting it what I'm trying to say? Like in the
Yeah,
image also you can see that the fumes are shown in this image right now. So it is very cold. The temperature is minus 78 degrees Celsius. So all these are the examples of physical changes which we can see over here. By the way, in the first image you have the following things, like you have sense of sight, you hear things, sense of touch, sense of a smell, you measure the different things, feel. All these do not show any state. They don't have got any state. So something that does not have a state, something that is only in the mind or something which is that just a sense. So how can that go through a physical or chemical change? Like a emotion, can emotion go through any change? I mean to say that can it go through a physical or chemical change? It's absurd to say that. It does not make any sense right now. So things like sense, hearing, feeling, touching, smell, or measure, they don't go through any physical or chemical changes. It's a general thing. Okay. Then have a look at this iron blade. What is happening? This iron blade, or particularly would be iron knife, it is going through a physical change or chemical change. You can clearly observe that it is heated. That's why it has turned red hot. Hmm? What you guys are observing here, that upon heating a iron knife, its color changes to red, and after it will cool down, it will retain its original color. It will get back to the original color. So thereby, you guys tell me, is it a physical or chemical change? This is a physical or a chemical change? Yes, Abu. It's obviously a physical change now.
physical.
Why is it so? Because the color of the object can be changed back to the original color. The color of the iron blade can be changed back to the original color. So first characteristics, like one of the characteristics of a physical change is that in physical change, color can also change, right? And it is reversible in most of the cases. In physical change, if the color is changing, for the most of the time, it is going to be a reversible change. Further, what are the phase changes here? See, whenever the phase changes refers to basically change of a state from change of the substance from one state to another. Also, both of you turn your cameras on in the class. Both of you are required to turn your cameras on in the class. See, you have a solid object. You heat it, then it goes into the liquid state. You heat it further, it converts into the gaseous state. Furthermore, what is happening here? Energy is being transferred here. Energy is being transferred. How? See, you guys tell me, in order to heat any solid object, you have to provide the heat now. So the solid object is said to be absorbing the heat. Getting it? Further, when it is heated more, then it converts into the liquid state. Now from the liquid state, you want to convert it into the gaseous state. You again have to provide heat to the liquid. So again, it is said to be absorbing the heat. Getting it, guys? Abu, are you getting it? Priyanka, if you have any doubts so far, you can type in the chat box if your mic is still not working right now. So then it goes to the gaseous state. Now understand it in a very detailed manner. See, when you look at the particles inside the particles inside the solid are very compact. They are very closely packed. They are going to be like this. So they are closely holding each other. All these particles are closely holding each other. By the way, am I visible to everyone in the class or not? The particles of the solid are closely packed into each other. They are holding each other very firmly. So they now, if you were to look at the particles of the particles of the liquid are at some distance from each other, like this. They have some gap between them. Getting it, guys? So their force of attraction is not that much stronger. While when you look at the particles of the gas, their particles look like this. They are very far away from each other. So the force of attraction in them is very less. Are you guys getting it so far, what we are discussing? Please answer
Yeah.
yes or no. Good. Priyanka, if you have any doubts, please answer it in the chat box. Mean to say that, ask in the chat box. Now further, you get to know that why these particles are held very close to each other, because they have got a force that keeps them together, simply as simple as that. So the force of attraction between particle is maximum, it is less, and it is very less in the case of gas. Now, in order to separate these particles, in order to separate these particles and make them like this, you have to provide them with some energy. Getting it, guys? So heating this provides the particles with some energy, and those particles starts to shake. The particles start to vibrate. They start to move here and there, and then they convert into the liquid state. Right now, so they are going to shake and vibrate here and there. And why they are vibrating? Because of the energy that is provided to them in the form of heat. So then they will go into the liquid state. So while providing the heat energy to the solid object, it absorbed the heat, and the particles started to vibrate and then converted into the liquid state. So heat is said to be absorbed in this conversion from solid to liquid state. Is that much clear? Right now. So we can say, let us say, for example, let us say the 100 joule of energy is provided. The unit of energy is joule now, Joule. So 100 joule of energy is, let us say, that is absorbed in converting the substance from solid to liquid state. Further, say that again you have to convert now from liquid to gas. Now look at the spaces between the molecules, between the particles of liquid and gas. In gas, they are much farther away now. So molecule, meaning that force of attraction is still existing in the liquid right now, but you need to make it weaker. How you are going to make it weaker? By heating it. So once you heat it, they again start to vibrate more and more. So they will vibrate further, and will get away from each other, and then they convert into the gaseous state. So here again, energy will be absorbed. Let us say that here 200 joule of energy, for example, let us say that is absorbed. So we can say that while the solid was converting from liquid, heat was absorbed, heat energy was absorbed. Again, from converting liquid to gas, again heat was absorbed. So energy is absorbed when change is happening in this direction. When change is happening in this direction, energy will be absorbed. Is that much clear to you, to everyone in the class or not? Priyanka, did you got it? And Abu, did you got this? Hmm. If yes, then we can move ahead. Then. Now you guys tell me what should be happening if we do the reverse. Very good, Priyanka. If we do the reverse, we convert from gas to liquid and from liquid to solid. Then in that case, they are going to lose the energy. Because keep this thing in mind, the particles of the substance is gaining energy. So they are gaining energy. Here they gained energy to convert into liquid. Here again they gained energy to convert into gases right now. So they are having high amount of energy. Now to convert into the liquid state, they need to lose the energy. Again from liquid to the solid state, they again need to lose the energy. So energy is released whenever the substances are converted from the gaseous state to the liquid and from liquid to the solid state. If you guys have understood this, please tell me. Abu, did you
Yeah.
got this? Okay. So explain this to me, Abu. What did you understood from this?
Sir, I have understood the
Hmm.
physical change of matter from one phase to another due to transfer of energy.
Transfer of energy. Good.
When
From solid to gas.
energy is
Mhm. Continue.
uh,
Yes.
I forgot what to say.
Priyanka, see if your mic is working now. Still, it's not working. Okay. Did your smartphone fell into water or in something? Maybe that has happened. Okay, anyways. So that is the case. Whenever it converts, simple thing is that if you find it complex, simple understand. Like from solid to liquid, what you have to do. Okay, Priyanka. What you have to do, you have to heat it now. So energy is absorbed by it. Huh? From so liquid to gas, you have to energy is absorbed in this process also. Right now. While gas to liquid, so the particles are having excess amount of energy. The particles of gases are having more energy as compared to the liquid right now, as compared to the particles of the liquid. So from this state to go to this state, from having a higher state of energy to go to a lower state of energy, they have to lose some energy. Further, the particles of solid, we know that they're having least amount of energy right now, while liquids are having some amount of energy. So they also have to lose the energy in order to convert into solid state. So that is the thing which happens in the phase change. Now, in all this case, what we have learned that water remains same, whether it be in the solid, liquid, or gaseous state. Water is simply water. It's not like water turned into carbon or sulfur or into something else. Water, here also it is water. It is made up of hydrogen and oxygen. Here also it is water, and here also it is water. The states are different, but the composition remains same. Right now, so in melting or in freezing or in condensation, we learn that the state does not changes. The state remains same. Getting it, guys? So hope you are getting it. So we say that another property of the physical change is that, apart from the first one, in the physical change, composition remains same. We have the example of melting, freezing, and condensation of water. You can, it's better to arrange it in this manner: freezing, melting, and then condensation. Freezing, melting, and condensation. So in all this case, the chemical composition remains same. That is basically it remained water. Compound of, yes, you guys should be writing these things down also. Can I forget to tell you? You should be writing these things down also. In the previous class, did you guys wrote anything, Abu? Did you guys wrote anything in the previous class? Please respond. No. Abu, your mic
No.
is working properly now. This is the common problem, like it happens in several classes. Okay, only a little bit. Okay, then start from writing from here. The headline that you will be giving is, um, just give me a moment. The headline you will be giving is this. Characteristics of physical change. Okay, and that is the headline. Characteristics of physical change. Write it down and do let me know once you are done. Now you guys tell me, while water was going through this physical change, huh? Or for example, when you break a piece of paper, hmm? When you break a piece of paper, or when candle is melting, is a new substance formed in all that? No, no new substances are formed there now. So another property is that no new substances are formed. We have several examples of such changes. For example, you have stretching of rubber, boiling of water, right? You have example of a stretching of rubber, you have boiling of water. Apart from this also we have several other examples, like the most common one we had this one, huh? Heating of the iron knife. Okay, write these things down, then we'll be moving further. Also, you guys tell me, aren't all these temporary changes which you are discussing, like this one is a temporary change and this one is also a temporary kind of temporary change, and generally all of them are, most of them are reversible. This is also reversible, this is also reversible. The stretching of rubber band, that is also reversible in nature, no? So another property about them is going to be, meanwhile keep on writing these things also, okay, now? So generally these are reversible in nature. Furthermore, we have also learned like energy will be either absorbed or released in the process of physical changes. Okay, now energy will be released or absorbed. But in majority of the cases, little amount of energy will be released or absorbed. Keep that thing in mind. Yeah, you have to write about the physical change here, Priyanka. Okay, you're asking about this one over here, no? This physical change. Okay, I thought you guys had already wrote this thing in the previous class. If you guys haven't wrote it down, first of all, wrote this thing down. Okay, no? First of all, note this thing down. Also, you guys work on your writing speed. Try to increase your writing speed. Okay.
Sir, did you look at my test paper?
No, I didn't got the time to look at it. Generally, you see, today also I was not traveling. Yesterday also in late night I was traveling. Okay, now after the class I will make sure I check it. Okay, now you have shared the syllabus. Have you shared the syllabus with me?
Yes.
Uh, okay, okay.
Sir, traveling where?
And we have finished these three chapters by the way right now. So believe you shouldn't be having a problem. Okay, now.
Sir, traveling where?
Yeah, actually, I had to go to a nearby district in order to purchase some medicines. Actually, that medicine was not available in my district, so had to go to a nearby district. Okay. Generally, like I had to wait for 2 to 3 days to get it online, but it was required in emergency, so thereby I had to travel on urgent basis. Okay, done. Abu, have you uh, written the definition of physical properties?
No, sir, not.
You can write it down.
Sir, you went by train?
Yes.
You went by train?
Yeah, I went by train. That's the most common means of transport we take here.
Sir, if you took a aeroplane, it would be more faster.
See, I don't have the option here because, like, in just also it is not going to be economical now. Like, in order to travel from one district to another, um, via train, it is economical also, and it is the only option available. Like for bigger dense, in order to cover bigger distances, you have got aeroplane now, right? Also, particularly, for example, you have to cover a distance of like let's say um, 500 kilometer or 300 kilometer, 1,000 kilometer. Then train is not a good option. Then aeroplane is a good option. But you have to travel a distance of let's say 200 or 300 kilometer. Then train is I think it's the best option. Okay, everyone done writing this?
Yes, sir.
Okay.
Sir, you could also go by car.
Yeah, car. Yeah, that is also one of the option right now. But normally, I do travel with car like when we all have to go to a picnic or not particularly picnic, but when there's some family function or things like that, or there's some when you have to go to some tourist destination or like that within the state. Okay, now. Okay, night wrote these things down also. Okay, meanwhile, listen to what I'm saying also. Okay, now. So we learned that physical changes, most of them are going to be reversible. There are some other physical changes also. So there are many physical changes are reversible right now. Many of them are there. In that only their shape will be changed, their size will be changed. For a temporary amount, for temporary basis, color will also change right now. Like when we heated the water, that one we had the example of it. When we were heating the iron blade, we had the example of that one also. Apart from this also, you guys give some reversible physical changes. Example of Give some example of reversible physical changes apart from the ones which I gave you. Can you think of some other examples? Yes. Apart from the common example which we had, think of some other examples. It has to be physical and it has to be reversible in nature. Yes, Abu. Any other examples? Okay, you guys tell me, cutting of an apple is a physical change. Cutting of an apple is a physical change. Is it reversible or irreversible? Obviously, it's a irreversible change. But is it a physical change? Yes. Obviously, it's a physical change, no? Okay. Then to do tell me, kneading of flour into a dough. Kneading of flour into a dough. What kind of change is that? Kneading of flour into a dough. Priyanka, you should also answer this one. Kneading of flour into a dough. What kind of example is that? Hello.
Yes, sir.
Kneading of flour into a dough. What kind of change is that? Is that a physical change or is that a chemical change? Or is that a reversible physical change or irreversible physical change? Same for chemical. First thing is that obviously it's
Yes,
a
it's
hmm,
reversible.
it's a physical change. That is for sure it is a physical change. But is it a reversible?
Yes.
How do tell me this thing that how kneading of flour
And
into a
it
dough.
will just like, sir, you will,
Hmm. Yes, Abu, I'm listening.
sir, if you dehydrate it, then after that, then you smash it, then it will become powderish. Then if you add water, then it will be irreversible. Then you can again knead it.
Okay.
It is reversible.
In that manner, you can say. In that manner, you can say that. Okay, now. In that manner, you can say that it's a physical as well as a reversible change. Correct. All of you done writing this? Now, tell me, once you make a chapati out of it, then can you convert chapati back into dough?
No,
Also here, the chemical structure is changing now. Once you bake the chapati, once you
uh,
bake, hmm,
chemical change.
it's a chemical change right now. Okay. Do let me know once you guys are done writing it. Next, we are going to learn about chemical changes. There you will get to know that it will occur when chemicals would be reacting with each other. Different chemical substances would be reacting with each other. Uh, and new substances would be formed. In almost all the chemical changes, new substances are formed. Apart from that, you will get to know that there will be change in color. There would be evolution of gases. There could be evolution of gases in a chemical change. New substances would be formed in a chemical change, and all the chemical changes are irreversible in nature, meaning that you can't get back the original product back right now. Also, chemical changes, guys, now sometimes it is called as chemical reactions also. Okay, Priyanka, do let me know in the chat if you are done or not. Done? Okay, good, Priyanka. Abu, what about you? Please write it down quickly. Hmm. So I was telling you guys about chemical changes. Okay, now chemical changes. Like you can have different examples now. Like you usually get, like you have gates. Like you can see iron gates of parks. After some time, what happens? It starts to rust now. Iron benches in lawns and in gardens. Almost every article of iron, when they are kept in the damp air, when they are kept in the open air, it gets rusted. Different agricultural tools gets rusted. Why does that happen? Because it reacts with the air and water to form a layer of rust above it. Or have you guys observed this thing, that if you were to have um, copper pipes or objects made up of out of copper, thereby you will see that it develops a layer of green color above it. Can you guys relate with what I'm saying? Do you guys observe that ever? See, this is what I'm talking about. Talking about corrosion of copper. Look at the third image, this one, or look at this one here. You can see there are some green colors developing on the copper pipes. Yes, Abu and Priyanka. Here also a new product is formed. This has gone through a chemical change now, right now. So new products are formed. Uh, Then when you look at rusting, hmm, in the case of rusting also you see that the new products are formed. Is that the original color of the iron? No. Good, Priyanka. So you have seen it, good. So this is not how originally iron looks like. Metals are having a shiny luster. Now they have a shiny color. They reflect light. They are good reflectors of light rays. So why all this that happens? Because of chemical changes going there. Some chemical changes are taking place there. We are going to learn about that. Before that, we have some questions to do. Okay, now. By the way, Abu, were you done writing that?
Yes, sir.
Okay, good. So question one says that give one example of each kind, showing that a change in energy takes place when a physical or a chemical change occurs. So we have a very good example of where an energy change takes place. We had the example of heating of water, heating of ice cubes, then it converts into the liquid state, and then it goes into the vapor state. So energy is changing here now. Getting it, guys? So in this process, what is happening? Energy is absorbed, right? So energy changes takes place during a change in the state. A solid absorbs the heat. The solid will be absorbing heat in order to melt and convert it into liquid. Liquid will further absorb heat to convert into the gaseous state. So energy is changing here. Upon cooling, the vapors will release the heat. Upon cooling the gases, it will convert into the liquid state, and the gases will release the heat, the extra heat it had, it will be released. Gases of liquid, upon converting into the solid state, they will also release the extra heat they had. Although you might not feel this, like when you touch water, water will feel cold, but it actually has a very small amount of heat energy in it. You might not able to sense it, but actually it is there. So heat is given out when it converts from the gases to the liquid and then to the solid state. Then we had the example of energy change. If you were to take the example of this change going on in the nature, hmm, where the producers, mainly the autotrophs, that is plants, the chloro green pigment found in them, that is chlorophyll, would be taking the sun's light. They would be absorbing the heat. They would be absorbing the light energy from the sunlight in order to do the process of photosynthesis. Now, so in this process, energy is absorbed or not? You guys tell me. Photosynthesis, in this process, energy is absorbed now. Right now, I'm not talking about whether it's a physical or chemical change. We are only learning absorption or release of energy in a change. Although it's not a change from solid to liquid state, it's a different thing. But a energy change is taking place here. It is absorbed. Now we know that when plants will be dying, when animals will be dying, so their body will be decomposed by fungi, bacteria, and worms. And whenever dead and decaying plant and animal matters are decomposed, upon decomposition, heat energy is released. That's why if you were to prepare a compost or you do vermicomposting, so if you open the vermicompost pit, you will observe that lots of heat will be coming out of it. Have you guys observed that? Lots of heat will be coming out of it. It is because of the decomposition process going on inside it. Is that much clear to everyone or not? Hello, Abu and Priyanka. Abu, is it clear to you? Priyanka, you're not getting it. See, moments ago we were talking about energy change. In the case of physical change, we learned that while the state changes from solid to gas, heat energy is absorbed. In the opposite, that is from gas to liquid and then to the solid, heat is released. That was one such an example. Then right now we are talking about energy change, and this one can be considered as energy change taking place. This one can be considered as a energy change taking place in a chemical change. The process of photosynthesis is a chemical process